Hello again. We're back in the Igloo. Well, anyways, hello. How are you today? In this video, we talk about basics and at the same time, all the slopes, 1 through 10. So stick around to find out about the bases. It's pretty fun. Well, anyways, enjoy the video and have fun while watching. Bye. So, what is basics? In general, what are the basics behind the bases? In this video, I discuss the basics behind the bases from 1 to 10. Today is a happy day. Today's video was requested by a viewer. Remember, if you want a math concept or idea discussed on my channel, make sure to comment down below or email me. My email is thepenguinbrain@gmail.com, also in the description. The viewer asked me to explain base 6, but explaining one base discretely explains many other bases, and thus I will explain the basics of bases 1 through 10. If you would like me to explain the bases after 10 and how they work, or converting between the bases, make sure to comment down below. Now, let us start the discussion of the bases. Cool. Well, I count in base 10. Oh yeah? Well, I know the octal system. But what is base 10? What is the octal system? By the end of this video, you will be able to answer all of these questions. When talking about the bases 1 through 10, let me start with the base easiest to understand, which is undoubtedly base 10. Base 10 is probably the easiest base to understand because it is the base that we use. By the base we use, I mean going 0, 1, 2, all the way up to 10 and beyond, etc. But I won't stop at just that. We need to understand how one can tell the difference between base 10 and base 9. Here, I show the first 30 digits of base 10, some of which have a tens digit of 0, some of them of 1, and some of 2. But the important idea to take from this is that between every change of tens digit, there is a very special amount and order of numbers. In base 10, there are 10 different characters representing a number. Why I say characters representing a number and not numbers will be explained to you shortly. Here, I will explain the schematics important to the idea of using base 10 to understand future bases. First, I have our 10 unique characters going in order from left to right. This represents the first 10 numbers in base 10, 0 through 9. What would happen next, going in order, is the ones place going back to 0 from 9 and repeating the 10 character cycle. Then the tens place would go up by a placement, on and on and on until we reach the number 99. This is what we should understand of base 10 for now. Soon, we will try and use this pattern to discover base 6. Now, we are to our original equation after playing around with base 10. What is base 6? Looking at what base 10 is, with 10 different characters representing a number before repeating them, as 10 is a combination of previous characters, this is what I have concocted for base 6. There are a total of 6 characters, 0 through 5, and then the 1 cycle would repeat while the 10 cycle moves up. If you understand this, great, and if not, I will soon show you counting with base 6. So base 6. There are 6 unique characters. I say characters because these numbers are not the quantities themselves. They are a representation of a quantity for our own leisure. If we didn't have these representations, we would represent 7 by drawing 7 units instead of 1 character. Our ancestors were pretty smart peeps. But anyway, I have 6 different characters. Going in order with their names, I go 0, 1, 2, 3, 4, and 5. Because I started with a tens place of 0, now I move the tens place up a character, now with a tens place of 1. I keep going, 11, 12, 13, 14, 15, and then up to 20. By now it should be making a little more sense of how base 6 works, so I will zoom ahead. As 5 is the last character in the 6th number cycle, having 55 is like the equivalent of having a 99 in base 10. Now what do I do? In base 10, I would change the tens digit to a 10. So that is what I will do here. Doing this will take you a long way in counting base 6, so let us move to another base. Starting up and moving down, base 9 follows the exact same pattern as base 6. With, yup, you've guessed it, 9 total characters. Once the first cycle of the 9 characters is gone through, the tens place moves up another spot, starting from 0 and moving to 1. Skipping to going to the 3 digits, once at 80, we go until 88. Because 8 is the last character in the cycle, we can treat it again as a 99 in base 10. In base 10, we go to 100, and that is what we will do here. We go from 88 to 100, then it is more counting from there. For bases 1 through 10, bases 3 through 10 are pretty much the same thing. See if you can spot a pattern. For finding the pattern, I suggest to try looking at the name of the base and the characters in the base. Anyway, this here is counting for base 8, base 7, base 5, base 4, and base 3. Earlier, I asked you to see if you have found a pattern. If you think you have found it, great. If you have not or do not want to find it, then keep watching. If you want to find the pattern with a desire, then I suggest going back and looking through the bases. Well anyway, moving on to the pattern itself. Bases 1 through 9 do not contain their respective number. For example, base 6 has 6 characters, but none of them are actually 6. It is a funny quirk with the beginning bases, but important for understanding future bases. Now I will move on to base 2 and 1, both a bit funny. One is very common and the other is very impractical. See if you can find which is which. With base 2, we only have 2 characters representing a number, 0 and 1. Note that 0 and 1 have a tens digit of 0, the first number in the sequence. Because we have already reached the end of the cycle, we move to the next number in the sequence for the next tens digit, which is 1. Here is where it gets a little trickier. We have run out of the 2-digit numbers we can make with base 2, so we need to go to bigger heights. After 11, the tens digit jumps to a 2-digit number, if that makes sense, from a 1 to a 10. Then we continue the cycle, until again we reach the same dilemma with 111. Here, we do the exact same as before, like so. For those of you who are into math or computer technology or code, this sequence might look familiar to you. I will tell you, yes, it is what you were thinking of. Base 2 is equal, synonymous even, to binary. In fact, every single base has a name. Here is a quick table with the names of the first 10 bases, but the list goes on infinitely, as many names for the bases as there are numbers for the bases. If you want me to discuss this in another video, make sure to comment down below. But now, this leaves us with our last base, base 1, or unary. From pattern applying before, we know that bases 2 through 9 do not contain their respective number. I will tell you here that the same is true for base 1. So this leads us to a stump in the ground. We know that base 1 does not have any 1s. So what now? stick around to find out. First, I will review what I have been talking about in this video. Numbers are not the quantities themselves, but a character representation of the quantities. We can represent 7 with 7, let's say, dots, but it is more convenient to write the character for 7. This can lead us to a workaround. While we can use 0, our last character, we can select a brand new character for base 1. For those of you interested in bases 11 plus, this is what we would do. Arbitrarily pick a new character to represent the added number. Let us pick a triangle to represent our number for base 1. Then, counting in base 1 would look like so. To represent 1, we would have one of the triangles. But now we have reached the amount of characters in our sequence. We know this from before, so now we need to move up a spot to our next 10 digit represented like so. And yep, you've guessed it. To represent more numbers, like 5, we have 5 triangles. To represent 11, 11 triangles. So I guess what we can conclude from this is that base 1, also known as unary, is impractical to use. Why represent 7 with 7 characters compared to just 1 character? Anyway, now we move on to the cliff notes of this video. In summary of this video, for bases 1 through 9, we have learned they do not contain the number of the base. Base 6 does not have a 6. We also know that all bases have unique names to go with them. For example, base 2 is more commonly known as binary. Thank you for watching this video. If you enjoyed what you like, make sure to comment down below. If you didn't enjoy what you saw, make sure to comment below what you would want instead. Or my email is thepenguinbrain@gmail.com. Thank you for watching this video, and have a nice day. Hello again. How are you? So, I've been talking about bases a lot, and I'm wondering, if I ask you a question, would you be able to answer it? Well, this one's not really a question per se, but kind of an application question, if you see what I mean. So here's the application question: is base 0 possible? Hmm.